Welcome to the Explainer. Today, we're demystifying the world of data science, and we're doing it with its #1 tool, Python. So let's crack open the Python Data Science Handbook and see what all the buzz is really about.
So you've probably heard the term data science a lot. I mean, it's thrown around constantly in tech, in business, pretty much everywhere. It feels like it's taken over. But with all that hype, it can also feel, kind of vague, right?
And let's be honest, you might even be a little skeptical. Is this really something new? Or is it just a fancy label for stuff people were already doing? Maybe a little something extra to salt your resume, as they say? Well, you are definitely not alone in thinking that.
In fact, our guide for this explainer, the Python Data Science Handbook, kicks things off by addressing this exact point. It acknowledges that, some pretty vocal critics have called it a superfluous label. But the book argues that view misses something really, really important.
Okay, so if it's not just a buzzword, then what is it? What are the actual concrete skills that make somebody a data scientist? Well, as it turns out, it's not just one thing.
The key idea, which comes from Drew Conway's famous Venn diagram, is that data science is really the intersection of 3 different worlds. First, you've got hacking skills. And we don't mean the bad kind, we mean the practical computer science ability to grab, store, and process data. Then you need math and statistics knowledge to actually model that data and figure out what it's telling you. And finally, and this is so crucial, you need substantive expertise. That's just a fancy way of saying you need to know your subject, whether it's finance or biology, so you can ask the right questions and understand the answers.
And that's the real definition. Data science is that powerful, cross-disciplinary sweet spot. It's where the skills of a coder, a statistician, and a subject matter expert all come together.
Which brings us to a really fascinating puzzle. If this field is so specialized, why on earth did Python, a flexible, do-anything language, become the tool of choice? I mean, it wasn't built for this stuff at all. So how did it completely take over? The secret, it turns out, wasn't about what Python was designed for. Nope. Its incredible power comes from its community, a huge, active community that built an entire ecosystem of specialized tools or packages right on top of the language, transforming it into the data science beast it is today. Okay, so if you've got all these amazing tools, you need a place to use them, right? A workshop. So let's step inside the interactive environment where all the data science magic happens.
And the handbook gives us the absolute perfect metaphor for this. Think of Python as the powerful engine. If that's the case, then IPython, or interactive Python, is your control panel. It's the hands-on, interactive dashboard you use to drive that engine.
And like any good control panel, this one comes loaded with a set of specialized power tools. These are those community-built libraries we were just talking about, the ones that make Python so incredibly good at its job.
Now, there are 4 that you just have to know. They're the core of the whole stack. You start with NumPy, which is the bedrock for handling massive arrays of numbers super efficiently. Then there's Pandas, which is brilliant for working with data in tables with labels and columns. Think of it like a spreadsheet on steroids. But what good is data if you can't see it? That's where matplotlib comes in, letting you create just about any chart or plot you can dream up. And finally, when you're ready to make predictions, you've got scikit-learn, which is your gateway to a vast world of powerful machine learning algorithms.
But working in this environment isn't just powerful. It feels fluid, responsive. Sometimes it even feels a little bit magical. And a lot of that feeling comes from some special features built right into that IPython control panel.
So picture this. We've all been there. You're in the zone, you're coding, and you know you need a specific function. Let's say l.insert, but you can't quite remember the arguments. The old way, you'd stop, open a web browser, search for it, and your focus is just gone. But here, you don't have to do that.
Instead, you just type the name of the function, add a question mark, and hit enter. And boom, the entire documentation for that function pops up right there, right where you're working.
And that is why it feels so magical. As the handbook says, it radically shortens the gap between question and answer. It keeps you in the flow. It makes your work faster, smoother, and just way, way less frustrating. It's a total game changer.
All right, here's another classic problem. Let's say you've got 2 different ways to write a line of code. They both work, but you want to know which one is actually faster. How do you figure that out reliably?
Well, you guessed it, there's a magic command for that too. You just type %timeit right before the code you want to test. IPython then runs that code over and over again to get a really accurate and stable measurement of how long it takes.
And just like that, you get a precise answer. In this case, 325 microseconds. It's an incredibly quick and dependable way to check your code's performance without ever leaving your workflow.
And all of this brings us to what might be the single most empowering idea in the entire handbook. The point isn't to go out and learn a totally new field from scratch. The real idea is to think of data science as a new set of powerful skills, a new toolbox that you can use in the field you already know and care about.
So I'll leave you with this final thought, the real question that all of this leads to. Once you have this toolbox in your hands, what questions about your world, about your job, about your passions, what questions could you finally begin to answer?